saying find the remaining zeros, first of all. They're not even asking for the polynomial yet. They're saying find the remaining zeros, assuming that you have real coefficients so that this thing actually exists. When you have a polynomial whose degree is 3, whose zeros are 2 and 2 minus I. So in this problem, they're not even asking for the polynomial's equation just yet. That'll be our next example, I guess. But in this one, they're just saying, what are the remaining zeros? Well, if you have degree 3, that means you could have up to 3 x-intercepts, right? One of these zeros is a real zero. It's the number 2. Okay, so that's an x-intercept. This zero, though, is imaginary. So these are both complex solutions, right? Complex means you have real and imaginary. So we have a real, we have an imaginary, but don't we have another one that's implied? Yeah, so the remaining zero, I think I misspelled that, remaining zero, in this case, would just be 2 plus I. So in the homework, that's what they're asking for you here. If they said, what are all the zeros, you would say 2 and then 2 plus or minus I would be sufficient. Right? That's a set of all zeros of this polynomial. The ones which are real, just 2. So 2 is the only x-intercept there. But all zeros would include imaginary as well. What about B here? I say you have a degree 4 polynomial. Now if it's degree 4, which is even, are you guaranteed to have any x-intercepts if it's an even degree? No, only if it's an odd degree. So you weren't guaranteed to have any x-intercepts, but look at the zeros they've given you. 0, so at 0 at the origin, we have an x-intercept. 1, so we have 2 x-intercepts being given to us. And then we have an imaginary 0. So again, what's our remaining 0? 2 plus I, and you're done with that problem. That was easy enough. So what did we do? We went up until the degree. Now, one thing that can happen, however, what if I had only given you 1 and 2 minus I? Okay? In that situation, if it's degree 4, you still know that 2 plus I is a 0, so that's a third 0. But in that case, if they're saying those are the only zeros that you have, then it must be the case that 1 is repeated. So it would have multiplicity of 2, wouldn't it? Okay? So remember, zeros can have multiplicity that is even or odd. Even multiplicity means at that x-intercept, you're actually touching and turning around. But odd meant that you cross through. So it could be that case. In fact, in some of my test questions, I'll say, this 0 has multiplicity 2. This 0 has multiplicity 3. And the polynomial has a degree of 8, something like that. And you can figure it out from there. So multiplicities are telling you it's been repeated that many times. So it's been accounted for. Okay, let's go to the harder stuff now. Let's talk about writing out the actual polynomial's equation.